So wave particle duality is a concept of what quantum mechanics which explains that light behaves as both as a particle as well as a wave. So in cases where they ask you to say what processes are able to describe the wave nature of light. So light undergoes photoelectric effect. You can talk about absorption and also emission of atoms. And then as a particle, light is able to undergo diffraction and interference. So there are a few things that we have to know when you're talking about light as a wave, and then when you're talking about light as a particle, so that we get to derive a formula. So we understand that according to Einstein's theory of relativity, the energy is related to mass and the speed of light using that very famous formula. Okay, so this formula is representing light as a mass. Now we are also looking at light to be a wave. So we talked about Planck's quantum theory, where we related the energy to be equal to Planck's constant multiplied by the frequency. Okay, I'm sure you're able to remember that. Okay, so we also know that the frequency can be expressed in terms of the division between the speed of light and what? And the wavelength. Okay, so far we are on the same point, right? So let's try to equate the two formulas. We see what we're going to have. So energy is the same, so we'll just get the right hand side of the two formulas. So we have the mass speed of light squared is equal to Planck's constant speed of light over the wavelength. So c squared means c times c, so one can go away. Okay, so cancel one c with the other c, so we remain with mc b is equal to that over the wavelength. Okay, so we're able to move. So note that the speed of light represents the velocity, right? The speed of light represents the velocity. So for the sake of generalizing it, because of course speed of light just represents when I'm dealing with a vacuum and whatnot, so we can write it to be mv is equal to Planck's constant over the wavelength, and then we can make the wavelength to be the subject by crossing and multiplying. So we have our wavelength being equal to Planck's constant over mass multiplied by velocity. So at this point, this is what we call de Broglie wavelength. So it is basically Planck's constant divided by momentum. We know momentum is a product of mass and velocity. So this is a very useful formula, and we'll be using it in a case where they ask us to determine the de Broglie wavelength, okay, given that they've given us the velocity and of course the mass. So this is what wave particle duality deals with, basically. So the concept itself identifies light to possess both wave and particle properties. Okay, so from that comes this formula of de Broglie wavelength, which is a very useful calculation under atomic structure.